5.2 is pretty much identities that are actually true, or not identities, expressions that are actually true. Very easy to remember, but it comes in this class, you don't have to memorize, you have to cheat the mark. They stand the line, you may not have that flexibility to understand. Your body uses alpha and betas, and these things stick with that. Sine alpha plus beta is sine alpha is sine beta plus is sine alpha times sine beta. This is an expression that is true. Good. Similarly, cosine alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. That is true. I'll show you why this is true. If you understand something, you don't have to memorize. That is my opinion. So, got this card. There are ways how I remember this. When I first learned a long time ago. When you have sine, think of it as distributing that sine. The first term would be sine alpha. Second term would be sine beta. And the terms that you multiply just split. You get cosine beta and cosine alpha. Same logic would hold true. But in this case, if you distribute, it's informal. You can't do it. But I'm just saying that's one way to easily remember. Here, imagine like distributing stuff, you have cosine alpha, cosine beta, minus and you flip. That's it. Good. Well, how do I go from here? For the difference of this, if it is minus, good. If it is minus, plus. Good. All I remember is the very first thing. I can come up with the second easily. All I did is flip the signs. So I converted. I saw positive, changed negative, positive became negative, positive became negative, but the sign negative becomes positive. But that came as the very first one, the sum formula. Now I have the equals formula. Naturally, if you did it for sine, if you did it for tangent, cosine, kind of slipped. The next one is tangent. So you would have tangent alpha plus beta. Yes? Well, where should you start? Should you memorize this formula in the textbook? Not necessary. Well, we know tangent x is simply sine x divided by cosine. Here, x is alpha plus beta. I can write it as sine alpha plus beta divided by cosine alpha plus beta. Good. I can rewrite the numerator. Yes. Using the identity, first one, I know sine alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. That is the first identity that I wrote. Sine alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. In a similar manner, the denominator cosine alpha plus beta, cosine alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. Good. Now, I'm going to pull that term out of the numerator. Yes. So if I pull that term out, I'll have that. Agreed. I don't have a term there, so it has to be in the denominator, so that would become sine alpha cosine beta. Good. Divided by, I'll keep that term as is for now. So cosine alpha cosine beta minus sine alpha sine beta. I don't want to write too much. That is all. Sine alpha cosine beta, yes, times 1 plus. What is sine beta divided by cosine beta? Tangent. Okay. And what is the other one? Tangent. But this time it is cotangent alpha. Yes. Denominator. I want to do something with that. So I'm going to pull cosine alpha, cosine beta out of the denominator. So cosine alpha, cosine beta. If I pull that out of the expression, first term would become 1. Second term doesn't have cosine alpha, cosine beta, so I would end up having sine alpha, sine beta, divided by cosine alpha cosine beta. If you distribute the term that I pulled out back in, cosine alpha times cosine beta times 1 would be that expression right there. Cosine alpha times cosine beta times that term would cancel out those two and would simply have sine alpha sine beta. Yes? If you find this too complicated, this is all I did. I have a minus b. I pulled a out. So a times 1 minus 1. Correct. If you distribute the a back in, you will get a minus b. That's all I did. Both in the numerator as well as the denominator. Now, I can get rid of cosine beta. Cosine beta. Is it possible to get rid of anything there? Yes, no, maybe. Not really. So sine alpha divided by cosine alpha is tangent alpha. Sine beta divided by cosine beta is easy. Correct. Yes. What is it? Tangent. Tangent beta. Yeah. With me so far? Now, cosine alpha is in the denominator. Can I write it this way? It's in the denominator. I simplified it. That expression is simply 1 minus tangent alpha tangent 2 beta. Agreed? Yes, no, maybe. Okay. My question to you, can I write sine alpha divided by cosine alpha as sine alpha over cosine alpha over 1? Yes or no? Who's friend? What's your name? Kiki. Is that right?
Yeah, that's right.
Okay.
What's the question?
Can I write sine alpha divided by cosine alpha as sine alpha over cosine alpha divided by 1?
Yes.
Do we agree? If it's too hard to see, this is all I did. A over B. I just did. Agree? Here, A is sine alpha, B is cosine alpha. That says, what is sine alpha over cosine alpha? Tangent. So, do you have a question? So, tangent alpha times 1 plus tangent beta times cotangent alpha over 1 times whatever term that I have, 1 minus tangent alpha tangent beta. Almost done. I'm going to distribute tangent alpha inside the expression is square brackets, so tangent alpha times 1 is tangent alpha plus. You can tell me what you will get if you multiply tangent alpha by tangent beta cotangent alpha. I am distributing tangent alpha. So this term times 1 tangent alpha. If you multiply tangent alpha by that expression, tangent beta times cotangent alpha, what will you get? Okay. Tangent beta, why?
Because tangent alpha times 1 over tangent alpha. This is
What are you getting 1 over tangent alpha?
cotangent.
Cotangent. So cotangent is 1 over tangent. So if you multiply tangent by cotangent, you will get 1. Multiply sine by cosecant, you will get 1. Cosine by secant, you will get 1. So tangent times cotangent alpha is 1. So you simply have tangent beta over 1 minus tangent alpha tangent beta. Good. That is the formula. Now, what about alpha minus beta? What trick did I use when I wrote sine of alpha plus beta, cosine alpha plus beta? And then I had to find sine alpha minus beta. I did something. What did I do? What did I do with the signs? I simply split them, right? Same logic. I'm going to change pluses to minus and minus to plus. So, if you want tangent alpha minus beta, it is simply tangent alpha minus tangent beta divided by 1 plus tangent alpha tangent beta.